Hello everyone. So today we are going to be talking about variadic functions in C. Variadic functions are functions that take in a variable number of arguments. A good example of a variadic function is a printf function. Let me just write a simple printf function here and show you what exactly I mean by a variadic function. Let's say printf. Let's just start by printing a string. We have, let's say printf my string, and we compile our code and run. So let's say gcc, compile it again, and then we run it. So we get my string. We could also say, let's print some integers, and let's say print some integers, and then on a new line, and then we can put here an integer, then we compile again, and then we run our file. Yes, and we have 56. We can also say, let's add a float. And then we can add here, let's say 89.34. Then we can compile again, and then we run. Yes, and we have a float. So how can we go about creating functions that behave like our printf function here? So I'll give an example of an ordinary C function here, which adds two integers a and b and returns their sum. So let's call our function add and put in two arguments here. Let's say 45 and 35. And then we compile it. And run. So we get 80, which is the right answer. Of course, it's what we expect. But if we want to add, let's say, 3 integers, we compile our code once again, and oops, we get an error. Too many arguments to the function add. What can we do to make our function add accept a variable number of arguments? So for us to make this possible, there are basically 6 steps that we need to take to be able to make this function of ours variadic. So the first and the most important step is to include the header file stdarg. So this header file includes all facilities that will help us handle variadic functions. Okay, all facilities that are used for handling variadic functions are found in the stdarg header file. So before you proceed to do anything with variadic functions, make sure you have included the stdarg header file. The next step is to define the function itself. So here I've given an example of our function that we want to use to add a variable number of integers. So it returns integers, the name is still add, and then the first argument we are giving to this function is an integer n, and then ellipses. To avoid any jargon, I'll just call this plus ... But this ellipses basically tell the compiler that the function we are declaring here takes in a variable number of arguments. So let's go ahead and adjust our add function to look something like this. So instead of a, let's put here n, and instead of b, let's put here the 3 ellipses. Okay, the next thing we do is to define a variable of type VList, which will store information of our variable arguments. So this is basically a pointer that points to our arguments in the function. So let's go ahead. Let me just let's clear this quickly, and then we start by defining our variable of type varlist ap. Okay, the next step, which is the 4th step, is we initialize our variable to point to the last fixed argument. In some cases you can have function that take in a fixed argument. Let's say int n. It could also be a char, a character pointer. It could be a character pointer. So for this case, our variable of type VAList will point to char. But for this specific case of add, our last fixed argument is int n. So we shall make AP point to our last fixed argument, which is n. Okay, let's go back to our steps here, and then the next step is to call the Variadic function that returns the value of the next optional arguments. Okay, so to do this we need to include a for loop, okay, that starts from I is equal to 0 and is less than the number of arguments. The number of arguments for this case for our variadic function is n, and we shall increment I continuously until it reaches n. Okay, so for purposes of just understanding the Variadic function, I'll say let's store the return value of Variadic in an integer x. Okay, Variadic in an integer x. It takes two arguments. The first argument, of course, is our variable VAList, which we said is AP, and then the return value of our argument, which is an integer. All right, so let's just print x to see what happens here. Let's print x to see what happens. Our x is an integer. Let's print all this in a new line. So let's say x. And then, of course, lastly, before we forget, we need to end access to our VAList variable AP. Okay, so let's try to call our function. Okay, no, let's not call it first. Let's just run it with this to try and understand how Variadic works. All right, let me just double check to see if I include all the steps that were necessary. So what we did was we defined a variable type VAList and we called it AP. Then we initialized it to point to the last fixed argument, which is int n for our case. And then we went into the for loop and initialized the variable I, okay, to start from 0 less than n I plus plus. So it will loop through Variadic and get all the return values that it will give us. Okay, just double checking to make sure all our syntax is right. All right, it looks good, so let's try recompiling it. Let's try recompiling it to see if we'll get the output that we desire. So let's compile, and then we run our file. Okay, printf x. What issue do we have here? Okay, let's first remove this return value here. Okay, and then we try to compile again. Then we run our file. Ooh, what's the issue here? Okay, let's call add. Okay, let's call add. We didn't call add in the main, sorry. Let's call add in the main. Okay, let's say add. Let's take 4 arguments. Let's say 89, 56, 33, and 78. Let's call it that way, and then we compile again. Then yeah, so this is basically what happens when you call Variadic. It returns our variable arguments. Okay, so for each iteration it returns 1 until we reach the last argument. So this is basically what happens. So what we can do here is to play around with that to try and get all those return values and add them up. So let's adjust our function to be able to add this up. So for, let's say, sum what we will do, let's initialize sum as well at the top here. Let's say int sum equals to 0. So sum will be equal to plus equals varg, and of course we put in the two parameters that the function takes, the two arguments, which is our variable ap and the return type, which is an int. So we of course end, and then we, in the end of our function here, we return the sum. So we have here 4 arguments to our add function here. So let me first clear the screen, and then we try to run this function again. So we compile. Oh, return sum, I forgot the end of line. Okay, so we clear this, then we try compiling again, then we run our file. Okay, what's the issue here? Okay, let's print it out. Printf. Let's say the sum of the integers is %d in a new line, then we close our double quotes. Let's try this now and you see. Let's recompile, then we run our file. Ooh, still errors, still giving us errors. Where is this coming from? Oh, I forgot to include the add here. Okay, so let's recompile. Wow, where is this coming from? Okay, let's do that and see. So clear tcc. Okay, all right, the sum is 256. So let's try. Now we want to add 2 integers. Let's say we have 33 and 78. I don't know that off head, but let's see. Let's recompile. Okay, yeah, and it gives us 111. And this is what we wanted. We wanted a function that we can call on anytime we want to add a different number of integers. Okay, so you notice that earlier in the printf it could accept different types of variable. For example, it could accept a float, it could accept an int. So how can we do something like this? How can we create a function that works in the similar way as the printf? So we want it to be able to do something like this. Let's say we call our function print, okay, and then we have certain placeholders where d stands for int, f stands for float, and then d stands for int, and then we call it in this way. We have the placeholders, and then we have here an integer 45, of course, with the placeholder d, and then we have a float 56.89, and then we have another float 12.43, and then we have another decimal, let's say 100. So we want to be able to call our function in this way and make it be able to print onto the screen what we want. Okay, so what we can do, we are going to use okay, let's declare a function. Let's call it void. It doesn't return any value. So void print. It takes in placeholders. So we have here placeholders. It's a string of placeholders, and then of course our ellipses. We already included the stdarg. So the next step is we have defined the function. The last fixed argument is placeholders, and then followed by ellipses. But in order for us to be able to track the length of our placeholders, let's include the string.h header file for us to be able to use the str len function to find the length of those placeholders. Okay, all right. Okay, so what do we do next? We store the length, int length of our placeholder in the length, and then we use the strlen function to get the length of our placeholders. So now we have that length and we can iterate over it. Next, let's declare an integer variable I that we shall use for iterating over the length of our placeholder, and then let's define our variable VAList to be ptr. Let's call it ptr this time, and then we initialize it with VAStart. Let it point to the last fixed argument, which is our placeholder. So ptr, okay, will point to placeholders. Okay, next we shall loop. So for I equals to 0, I has to be less than the length of our placeholders, and then we shall increment it. Okay, and then what do we do next here? So what we shall do is we shall use an if statement to check for a condition, if our placeholder is either a character I, or sorry, a character D or a character F, D being an integer and F being a float. So let's say if a placeholder in position I is equal to a character D, okay, if it's equal to a character D, then int x will be equal to varg. Of course, we include our variable VAList ptr, and then the return type is an integer. So we print x for this case, which is an integer in a new line, and then of course it's x, yeah. What else? If a placeholder in position I, if this is equal to a character F, int x will be equal to varg, our VAList variable. Of course, this is now at double. This is now a double value will be returned. So we printf. I know it's surprised we are using printf in the print function. Let me just correct this as well. It's printf, not print. But for purposes of clarity and understanding of variadic functions, let's just do it like this. So in this case, we print x. For this specific case, it's a float. Then of course this is x. Lastly, what do? We end access to our variable VAList. So in this case, our variable is ptr. So let's just double check to see if our syntax is correct. So what we did, we included string.h and stdarg. So stdarg is for variadic functions, and the string.h is to access the function for getting the length of the string. We initialize the function. We define the function as variadic with the ellipsis. The last given variable argument here is placeholders. and then of course we got the length of the placeholders and stored it in a variable length. We initialize the variable I that we shall be using to loop through the placeholder variable, and then we initialized, so we defined our variable type of VA list ptr, and then we initialize it to point to the last fixed argument placeholders, and then we loop through the length of our placeholders to try and see if there is any letter D or F, and if it's D we print an integer, if it's F we print a float, and then of course we ended access to our variable of type VA list. So let's try to print this out and see. So the first placeholder here is D, so it's an int. The second is a float, the third is also a float, the fourth is an integer. So let's try to compile and run. Ooh, int x. Okay, let's see the syntax error that we have here. Oh, our x here was a capital. Let's just change that as well. Let's change this x. Okay, and then this is a double. Even here is supposed to be double. Okay, now that you have made those corrections and adjustments, let's see. Let me clear my screen. GCC. Okay, let's try to run. Yes. Okay, let me just for purposes of clarity, let me recompile with a new line here for the floats. Let me clear again. Let's recompile, and then we run. Yes, this is what we get. We can even decide to change now from the function that you're calling here. You can make this dd f. So now we have here, let's say 78, and then we have another int here 58, and then we have a float, Okay, so let's try to compile and run. Okay, let's try to change our add function here also to add, to take in 3 arguments. So 72, 13 and 55. Let's compile and run. So we have here, yes, so our mini printf function for now does what we want, and that's basically what variadic functions help us to achieve. We do not need to write different function in case we want to add a different number of integers. So what we need to basically do is to use variadic functions, then we just change the arguments without rewriting the function. And I've also given an example of how we can use it to write a mini printf function, and I hope this clarifies the whole concept of variadic functions. Let me just quickly run through the concept of variadic functions again, just to remind you. So the first step is to include the header file stdarg that contains facilities that help us deal with functions that take in a variable number of arguments. The second step is to define the function. The function for variadic, the definition of a function that takes in variadic number of arguments, a variable number of arguments, includes ellipses. The 3 dots that you see here, always, they basically tell the compiler that this type of function is variadic and it takes a variable number of arguments. The next step is to define a variable of type VA list that is used to store information about our variable arguments. The next step is to initialize it to point to the last fixed argument using VStart. The last fixed argument here for our case was int n. However, you could have 2, 3 fixed arguments. VStart has to point to the last, VA list variable has to point to the last fixed argument. VArg returns the next optional argument. So basically it returns our arguments that we have given to the function. Then after it returns, we can use it to manipulate our variables, our arguments. when it returns those arguments, you can use it to manipulate those arguments to do whatever you want with them. And then lastly, we end access to our VAList variable. If you try to access the variable VAList with VARGs after VAN, you will not get any results. That's basically it. In case you have any questions, feel free to comment or reach out to me directly. But that's basically it. Thank you and enjoy your day.